After learning the basic rules and properties of logarithms, let's start with a combination of such. We have here the product property of logarithms. This tells us that if we have a logarithm of a product or a certain expression which could be factored out to the base b, we can simply break it into two logarithms and provide an addition process. Hence, we take the sum of the logarithm of the first factor x to the same base b and the logarithm of the second factor y to the same base b. Take note that the bases here must be all the same. This is very important because as part of solving logarithmic equations, there might be some instances here that certain variable exists here. We can use this property to solve for the given variable. But first, let's show that this is true so that we could apply this on our classes. Now, what we would like to do here is the idea that we are going to give representations to both of this, okay? So that we can structure our identity that from here we'll have that. We're going to let this here, okay? So partner with this. We're just going to start with the representation of these two. Okay, we're going to let the logarithm of x to the base b as a certain expression, let's say m, and the logarithm of y to the base b be equal to n. Okay? I know that if we are going to show proof of this, we should start with this side and going to that. But let's just have representation so we can use this as we move forward. In short, so with this, okay, since we have given representations to both of them, take note that we have the transformation rule. We have the logarithm of, say, let's use here a to the base b, which be equal to a certain variable, let's say k. Okay, there is a transformation from a logarithmic equation into an equivalent exponentiation, with this being our base. Okay, this k is our exponent, and the coefficient a is our equivalent here. So this works both ways, from exponential equation to logarithmic equation and vice versa. Why are we showing this? Because since we have established or assumed that the logarithm of x to the base b is m, together with the logarithm of y to the base b is n, we can have the exponentiation forms for both. So this would be b to the power of m, okay, b to the power of m, they have that, is equal to x. As we have this b to the power of m is equal to x. And another thing here, we will have b to the power of n is equal to y. As we, again, transform this logarithmic equations into this form. The reason, again, why we did this, because, as told you, we are going to start with this. So, the logarithm of the product of x and y to the base b can be equal into these expressions. We are going to use these expressions instead of x and y, and later on we're going to show that from here we'll reach to that. So please bear with me. Here's the process. It will become the logarithm of your x, which is b to the power of m, times, you will have here b to the power of n as your y to the base b. Hopefully you have been following as we have these representations now. Now take note, this is just one expression and we have here the same base, so we can multiply this using the multiplication law of exponents. This is the logarithm of b. You're going to add the exponents, right? Okay, to the base b, because that is how what will happen for our multiplication law of exponents. Now from here, I would like to introduce or reintroduce the inverse property of logarithm that we have also proven in the previous video. Please try to review that. That inverse property tells us that if we have the logarithm of a certain exponentiation, but the base is the same base of the logarithm here, this is equal to the exponent k. Okay, this is the inverse property of logarithm. Again, already proven in the previous video. That's why we started with that before this property. And what we can tell here is it follows the same structure. The logarithm of b, logarithm of b to the power of k. In this case, the logarithm of b to the power of m plus n to the same base b. This is just further equivalent to what is the exponent here, m plus n. Okay, So this is again following this. This is again by the inverse property of logarithm. Now, cutting this short, removing this, only copying these two. So we'll have here the logarithm of the product of xy to the base b is equal to m plus n. Again, this one here, the logarithm of product of x and y to the base b, that is this expression, is equal to m plus n as shown by this process. And what was m and n earlier? Going back here earlier, we let m as a logarithm of x to the base b, and n was the logarithm of y to the base b. So by substitution, the logarithm of the product of x and y to the base b is equal to m, which is this, the logarithm of x to the base b, plus this as our n, the logarithm of y to the base b. This is actually what our property is telling us, that if we have the product, or we can express our coefficient here as a product of two different factors, so we can simply break that into two different logarithms and add them, copying the first factor here and the second factor. And this was shown by this proof. So in order for us to prove this, we had this transformation, this representation and exponential equation by substitution here and the inverse property of logarithm. Going back here, we have now proven this product property of logarithms. So this is, again, properties, laws, and theorems. Please subscribe now.